All right, good afternoon. This is going to go over the end of Chapter 3 review. It's kind of 3.7, 3.8, just those two parts. We just went over going over how to factor GCF, greatest common factor, out of polynomials. So greatest common factor is the first one. And then we went over trinomials, which means three terms. And usually one of them is, the first one is an x squared or a t squared or an r squared, something like that. And then, so that was the type where it's like x squared plus 3x plus 8, something like that. And then the third type was hard trinomial. And that was generally something like 5x squared plus 3x plus 8, something where you have a number in the front of that x squared. Okay. Sometimes though they look like they're hard, but they're actually easy trinomials. That's because there's a secret GCF waiting to be taken out of all three. Okay. So always look for that GCF first to see if you can bring a 3 down to a easier trinomial. Okay. Sometimes they can have a GCF and still be hard trinomial as well. Okay. But that's what we just went over. So now let's go over the last two sections. I think this one's not as bad as factoring. It's going the other way, multiplying polynomials. Multiplying factors out to make products. So we have 3.7 multiplying polynomials. So we have something like this. This is supposed to be a 5. So 2r plus 5t, and then it's saying squared, which means everything in the bracket is times by everything in the bracket again. So we can write that out a little bit better. This is what the square means. Like that. Okay, so now we just have to FOIL this out like we've seen before. So 2r times 2r is 4r squared. 2r times 5t is 10rt. And then 5t times 2r is 10rt. And then 5t times 5t is 25t squared. Okay, now it's almost done. We have an RT and an RT. So we can go 4r squared. 10 plus 10 is 20. We just tack on the variables, and then we write this one at the end. We multiplied this out. Okay. One thing to note that's really important is you can't just take the squared and distribute it on the inside like we've seen. That is a big no-no. You cannot do that. The reason why is because there's a plus on the inside of the bracket. Okay, generally we do that when everything on the inside is being multiplied. But if you have a plus or a minus inside that bracket, you can't do that anymore. It's a big no-no. Okay, now we skip to one of the hardest type ones for multiplying polynomials, and we're done. Okay. So we can do this in different parts. I see a square here. So I'm going to start and just try to do this part first, because I see it's separated by a negative there. Okay, so we're going to go 3x times 2x, 6x squared. 3x times 4 is 12x. Now we move on to the next. Y times 2x is 2x. Y times 4 is 4y. Negative 1 times 2x is negative 2x, and negative 1 times 4 is negative 4. Okay. So now I've kind of opened those two brackets up. Now we're going to go into this next one. I write down this negative again, and I'm just going to write this in the better form. 3x plus 2y times the same thing. Okay. So now I'm going to rewrite everything there again. And now I'm going to expand out these two. The negative is still there though. Okay, negative. So with that negative, I still need to draw a bracket, because that negative is going to end up distributing on the inside of this. So what's 3x times 3x? 9x squared. 3x times 2y is 6xy. 2y times 3x is 6xy. And 2y times 2y is 4y squared. Okay. So last step is this. You could either bring those two together, or you can distribute this negative sign to 1, 2, 3, 4 to everything on the inside. So let's do that. Negative into the 9x squared, negative into the 6xy, negative into the 6xy, and negative to the 4y squared. So we're going to rewrite everything again. Negative 9x squared, negative 6xy, negative 6xy, negative 4y squared. And now I've gotten rid of all the brackets, so now I can try to simplify this huge monster of a question. So I look at the first one, x squared. Is there any more x squareds? There is right here. So what's 6 minus 9? Negative 3 x squared. Those are dealt with. Okay, I see an x here. Is there any more just an x? There's one there, one there. That's it. So what's 12 minus 2? That's 10x. Okay, next one we have 2xy. Any more xy's or yx's? Yeah, there's one here and one there. So what's 2 minus 6 minus 6? That's negative 10xy. Those are dealt with. Now we have a 4y. Is there any more y? No. So I can just write that. Now we have a negative 4 there. I can just write that. And then we have this left over, negative 4y squared. Alright, so I can't combine anything else. They're all different terms. So that's my end answer. Okay, so that's a completely good answer. Sometimes mathematicians like to write the highest degree first, so they'll have negative 3x squared. The next is negative 4y squared. This one's a pretty high degree, negative 10xy. And then they go on to the next one, like 4y, and then 10x. And then the one with no variable kind of goes on the end. But both of those are equally good answers. Okay, last section, 3.8, factoring special polynomials. So we have 4x squared plus 12x plus 9. This is called a special polynomial. The thing is, with this one, you can just do it our regular way. Okay, you first check if there's a GCF. There's not, because there's no number that goes into both 4 and 9. So now we go, this is a hard trinomial, so let's go 4 times 9 and see what goes into 36, multiplies to 36 and adds to 12. Okay, so it's the same type of question. So let's do it the normal way we would. 36, what adds to, multiplies to 36, that adds to 12, well 6 and 6, so we can go 4x squared, we can change that to a 6x plus a 6x, and then leave that plus 9. Don't write the negative 36, or the plus 36 I mean. And then here we take the GCF of the first two and the second two, so we can take a 2x out, and we have a 2x plus 3, and then here we can take out a 3, and we have a 2x plus 3, and then we write the inside bracket 2x plus 3, and what's not in brackets 2x plus 3. And one thing we notice is it's 2x plus 3 squared. Okay, the reason why it's special is they notice that this is a square number, this is a square number. Okay, 2 and 3 are the square roots of those two numbers, and we notice that 2 times 3 is 6, and so that's half of that number as well. So I'm going to leave it at that. Usually you can notice that if that's a square root, or that's a square number, that's a square number, then you can write it as their square roots, kind of like this. Square root of the first one plus square root of the second one, or of the last one, and then you just square it. Okay, but the middle number also has to be 2 times 3 doubled. Okay, that's a lot to remember, So generally, I would say don't worry about remembering if it's a special polynomial or not. Just do it the normal way you would normally do it, the hard trinomial way, and you'll get to the same answer anyways, okay? So let's move on to the next one, because there are special polynomials that you do want to memorize, like this one here, and they're called difference of squares. But this one we'll go over right now, because it's generally a hard trinomial problem. The only difference is you see different variables. You see a y in there as well. Okay, but nothing changes too much. Okay, you first say, is there a GCF that goes into all three? The answer is no. So then you ask yourself, let's see, it's a hard trinomial, so we'll go 2 times 3 is 6. So what adds to 6 that multiplies to 7? That's going to be a 6 and a 1, a negative 6 and a negative 1. So we're going to rewrite the first one, rewrite the second one, but when you rewrite it, you write an xy just like that. And then negative 1, xy just like the top one, and then you write this 3y squared, not the 6, the 3y squared. And then we have to take the GCF of the first two, and we have 2x, and we get an x minus 3y. And then I notice that there's nothing for this one except for a y, but I'm not going to write plus y, I'm going to write negative y, because that's the only thing that will make this bracket here the same as that one. So this will be an x minus 3y. And you write the one in the bracket because they're the same, and you write the one that's not in the bracket, 2x minus y. And that's that question. The special difference between this one and the previous ones we've been doing is there's just that extra y and that y over there. You just have to make sure to tack it on when you're going from this step to that step. Alright, question 3, this is the big part. This is the difference of squares. So the interesting thing about this, if I rewrite this question like this, 4x squared plus 0x minus 9, you can do that question as a hard trinomial problem, and you're able to do that right now. So you don't actually have to memorize a certain type of difference of squares, you just have to change it. You have to notice that there's no x term, so you have to make your own 0x. 0 times anything is 0, so you're allowed to do that. So once you do that, you can do a hard trinomial. What multiplies to negative 36 and adds to 0? Well, that's 6 and negative 6, and so on, and keep going and finish the question that way. But the one thing that you can also do with this question is you notice that's a square number. That's a square number. That's a negative sign, and there's only 2 terms. That's when you know it's a difference of squares for sure. And you can just go square root of this, which is 2. Square root of this, which is 3. This will always be a plus. And then you write the exact same thing over again. Square root of the first one. But this time you write a negative and the square root of this one. So it's just 2x plus 3 times 2x minus 3. That's the shortcut, and you don't have to do it this long way. You can if you want, but here is a quick way of doing it. So if you notice squared number, negative sign, then you can write square root, square root, square root, square root, plus negative. And that always works. Okay, this one kind of looks like a difference of square because there's only 2 terms. But if you notice, 5 is not a squared number, 80 is not a squared number. Okay, so what we do here is we can actually take a GCF out first. Okay, what number goes into both of those? A 5. And we're left with an x to the 4, negative 16 y4. Because 5 times 16 y4 gives us negative 80 y4. Alright, now this part is really a 1. 1 is a square number, 16 is a square number, and there's a negative sign. So we notice that it's therefore a difference of squares. So we can rewrite this 5, and we can notice, let's see, the half of to the 4 it's going to be x squared. And we notice that 1 times 1 gives us 1, so the coefficient here is 1. I'm not going to write it. And then we know with difference of squares it goes plus minus, so I'm going to go plus. And the square root of 16 is 4. And then the next one, we write x squared again. We write the same thing, but this time with a negative, with a 4. Okay? Now that one is done. The tricky one with this is you can keep going. If you notice that this is not a difference of squares because there's a plus there. Okay, that's a square number, that's a square number, but that's a plus. So this one, if you look, this is a square number, okay, because this is even. This is a square number, so, and there's a negative sign, so you can keep going. So let's rewrite everything we've written so far, and we can go, the square root of x squared is x, square root of 4 is 2, so we can go plus 2, and we can write the same thing, but negative. So overall, this one can be made into that huge thing, okay? 5 times x squared plus 4 times x plus 2 times x minus 2. All right, so that's a tricky one. You have to take GCF first. You have to notice a difference of squares. Then you have to notice a tricky another difference of squares within there. Okay, now it says back. We got to do one more. This one right here. 2x to the 4th minus 24x squared minus 128. First step, is there a GCF? There is, so let's take that out. 2, which gives us an x4 minus 12x squared minus 64, it looks like. Okay. And then here I notice it's an easy trinomial because there's no number here. So I can see what multiplies to negative 64 that adds to negative 12. I know 8 times 8, but that won't work. Let's see. 16 and a 4, that seems like it'll work. So 16 has to be negative and 4 has to be positive, so that those two, when they add together, equals this middle number. So let's rewrite that, x to the 4th, and we get negative 16x squared and plus 4x squared. And then we can write that negative 64 again. Okay. So now we can take this 2, and we can go, one thing to add is before I finish this, is since this was an easy trinomial and I found those two factors, I could have done a shortcut and just wrote 2x squared minus 16 x squared plus 4. I could have just wrote it like that. But I'm going to do it our normal hard trinomial way, just to show. And then we have x fourth minus 16x squared. Is there a GCF? Yes, we can take an x squared out, so that'll give us an x squared minus 16. And then this one here, we can take a 4 out. It'll be a plus 4, so we'll have x squared minus 16. They're the same, so that's good. And then we can have a 2. We'll write what's in the brackets, x squared minus 16. We'll write what's not in the brackets, x squared plus 4. And then we notice this negative 16 here, this one here can be factored further. This one can't be, but this one can be. The reason why is it's a square number, x squared, and a square number, 16, separated by a minus sign. So that's the difference of squares. So what's the square root of 1? Just x, or square root of x squared is just x. And then the square root of 16 is 4, so we'll write plus 4, x minus 4. That's the difference of squares there, so that's from there. And then we rewrite this one, x squared plus 4. Okay, so that is our further one. So this is an extra tricky question because you have to take a GCF out there at the beginning. Then it's a easy trinomial question to get down to this point. Then you have to notice there's a hidden difference of squares right there, but you can factor as well out to there. So there's 4 factors, 1, 2, 3, 4 factors for this product up here. Thank you.